Okay, you guys got the notes up? 1.5. There's two parts to this. It's called combinations of functions and then compositions of functions. We're going to do the compositions part on Monday. I just kind of want to introduce this to you. I think some of you might have seen this before in Algebra 2, but some of you may not have, so no worries. But when we talk about combinations of functions, when you combine something, guys, you just put it together, right? Combine like terms, that sort of thing. So the combinations of functions we're going to talk about are, you're going to be given 2 or 3 functions, g of x, h of x, y of x, L of x, whatever. And you're going to be asked to either add them, subtract them, multiply them, or divide them. All you're doing, in a sense, is combining like terms. It's the same thing that you would have done if you were just adding 2 polynomials together. It just looks different the way that it's presented to you. So you will be given, do you see these 2 different equations? There's a g of x and an f of x. The only thing that separates the 2 of them is the g and the f. It's saying there's 2 different functions. They both mean y, but it's just naming them. There's one is f of x, one is g of x. So in the first way that this is written, this says f of x plus g of x. When a problem is written like that, what do they want you to do with the 2 equations? If it's f of x plus g of x, what are they asking you to do? Add them together. That's it. Just combine like terms. If it's written like this, f of x minus g of x, what do they want you to do? Subtract. Good. If it's written like this, f of x times g of x, what do they want you to do? Multiply. And then if it's written like this, f of x over g of x, what do they want you to do? Divide. When you divide, you just have to pay attention to what's called domain issues. Because when you divide, what can you not have in the denominator? You can have negatives. What can you not have in the denominator? 0. So you just have to figure out what function values will make that 0. We'll talk more about that. It's called a restriction. It's just so the denominator doesn't become 0. All right? So let's just look at some problems. Before you guys look at me like, what are you talking about, all right? Here's my 2 functions. Write them down. F of x equals 2x plus 1. And then g of x equals x squared plus 2x minus 1. All right, we're going to do this problem 2 ways. We're going to do this problem 2 ways. Problem number A, or letter A, we'll call it. We're going to say, I want f minus g of x. Then B is going to be f minus g of 2. And I'll show you the difference. I'll show you the difference of what your answers will look like, how you answer the question. Do I have any domain restrictions? Is there anything I can't add or subtract together? No. So I don't have to worry about that. So the first thing I do is say, okay, I'm taking the g function and taking it away from the f. Does order matter in this case? Yes. Look at the difference between a and b. What's in the little parenthesis at the end? In letter A, there's a what? There's a variable. In letter B, there's a what? A number. If you have a variable here, then you should have variables in your answer. If you have a number here, then your answer should be what? A number. So all this is saying is take the f function. What is f? 2x plus 1. Subtract the g function. X squared plus 2x minus 1. Do we know how to do this? Do we know how to add and subtract polynomials? Tell me, Nick. We have to do what with this? We have to distribute this, right, behind here before I can combine like terms. So this is 2x plus 1 minus x squared minus 2x plus 1. Can we combine like terms? Okay. What's going to come first? What's the highest exponent you see? So I'm going to write negative x squared. What's a positive 2x and a negative 2x? It cancels out. Good. And then what happens when I have 1 plus 1? Plus 2. So there's your answer. F minus g of x is just negative x squared plus 2. All this is saying, guys, is take these 2 things and subtract them. You guys subtracted and added polynomials in Algebra 1. It's just written, the way that it's written is what's new. That's all. So in the next case, you might be given a problem, and it says, here are two equations, f minus g, but instead of x, what do they want you to plug in for all of the x's you see? 2. Now you can do this one of two ways. You can combine the two together and then plug the 2 in, or you can just plug the 2 in every x you see, meaning, I'm going to rewrite it. It was 2x plus 1, right? Minus x squared plus 2x minus 1. I'm not evaluating this in terms of x. I'm evaluating it in terms of what number? 2. So everywhere I see an x, I'm going to put a 2. So a 2 goes there. Minus 2 goes there. So am I going to have a letter or letters in my answer, or is it just going to be a number? No. It's just going to be a number. So we evaluate. Do your parentheses first. What's 2 times 2? 4. And 4 plus 1 is? So you have 5 minus. What's 2 squared? 4. What's 2 times 2? 4. So 4 plus 4 is 8. Minus 1 is 7. So what's 5 minus 7? Negative 2. There's your answer. So depending upon what they're asking you to do is how you deal with what you're supposed to have your answer look like. If they're asking you to keep things in terms of x, that means you should have x's in your answer. If they're asking you to keep things in terms of a number, then you just plug in that number for everything and simplify. Now, another way you could do letter B. You could combine the two functions first, which is what we did here, right? Right? We subtracted. And then you could take the 2 and put it in there. So if I said negative 2 squared plus 2, what's 2 squared? 4. So negative 4 plus 2 is how much? Negative 2? Same thing. So when they give you a function, when they give you, and I'll just do some examples here so you guys understand exactly what they're saying. If you have a bunch of equations and it says, add these two together, multiply them together, whatever, and then plug in numbers, you can combine them first and then plug in numbers if you want to. We'll talk about finding the quotient in a little bit. Well, let's come up here. All right, same thing. My f function, and then I have my g function. What are they asking us to do in this problem? What did I circle in blue? It says f plus g of x. So what am I going to do to the f equation and the g equation? You add them. You just combine like terms, guys. 2x plus 1 plus x squared plus 2x minus 1. Do I have to distribute anything? No. Can I combine like terms? Yeah. What's the highest exponent you see? X squared. Okay, so x squared. What's 2x plus 2x? 4x. Good. And then what's a positive 1 and a negative 1? They cancel. So there it is right there. So now if they asked you to do f plus g of 2, what are they asking you to do with 2? Plug it into everywhere you see an x and then just combine it. So what I'm saying is if you wanted to, you could say 2 times 2 plus 1 and then plug it into the rest of it. Or you can combine the 2 first like we did here and then just plug the number in there. Whichever way you guys want to do it is totally up to you, just depending upon what the question is asking. I'm going to do some examples aside from the notes to kind of make this a little easier for you guys to see. It's really not as confusing as it seems. What are they asking you to do here? Multiply, right? So you just take the two functions that they give you and you multiply. I don't really love these examples, so let me just mix them up. Hold on. Write this down. F of x equals x squared plus 3x minus 1. G of x equals, I don't know. x plus 7. Let's do it. Real simple. Okay, so here, you're given two functions. This is what something on your test will look like. And I say, okay, first thing we're going to do is we're going to evaluate g minus f of x. What does that mean to do? What does that notation mean? G minus f of x. You're going to write down the g function, write down the f function, and do what to them? Subtract. Should you have a letter? Should you have letters in your answer, or should you have a number? Letters, because it says to keep it in terms of what? X. That's what that means. So take the g function, x plus 7, minus, what is the f function? X squared plus 3x minus 1. All right, so we distribute first, right? X plus 7, and then I have minus x squared minus 3x plus 1, correct? You guys with me? We distribute that negative? Yes? Okay. So if we combine like terms, we have negative x squared. What's a positive x minus 3x? Minus 2x, great. And then 7 plus 1. There you go. That would be your answer. What about if the question said, f of, how am I going to write? Hold on. What does that question say? Multiply the two together. And replace x with 2. In this case, guys, I would not put a 2 in right off the bat. I'd go ahead and multiply the two functions together. So you have your f function is x squared plus 3x minus 1. And then your g function, x plus 7, right? This is a pain in the butt to multiply a little bit. I'm actually going to rewrite it so the binomials first. We're going back to algebra 1 here for a second. I just switched these two, which you can because it's multiplication. So now we have to distribute. So x times x squared is x cubed. Good. X times 3x is plus 3x squared. Good. And x times negative 1 minus x. Right? Okay, so 7 times x squared is plus 7x squared. 7 times 3 is plus 21x. And 7 times negative 1 is minus 7. And then let's combine like terms. So x cubed plus 10x squared plus 20x minus 7. You guys agree? All right. Now, is that the answer to the question? No. All we did was multiply the two functions together. What does the question want us to do? Plug in a 2 everywhere you see an x. So then you would just say, okay, well, I'm going to put a 2 here. And I obviously just made this up, so the numbers might get a little big. Sorry. What's 2 cubed? 8. Plus, I have to square 2 first here. So 2 squared is 4, and 4 times 10 is good. Plus, what's 20 times 2? 40, good, minus 7. So now we're just going to add left to right. What's 8 plus 40? 48 plus 40? 88 minus 7? 81. So your answer to this problem, f times g of 2, is 81. Does that make sense? The only thing that's new here that you guys haven't seen before is the notation. You guys have seen in Algebra 1 how to add polynomials. You saw that in Algebra 2, how to add polynomials, how to multiply them. All that's new here is, hey, when I say f plus g of x, what that means is add these two together and leave it in terms of x. Or add these two together and then plug in this number that's in the variable, in the parenthesis next to it. Yeah? Okay, I know it's Friday, guys. Killing me. All right, last one, and then I'll stop. What about if your problem said f divided by g of x? You put the functions on top of each other and leave it in terms of x. If it said f divided by g and there's a number, then you put f on top, g on the bottom, plug in that number. How is this one a little bit different? Well, my f function is x squared plus 3x minus 1 over x plus 7.
You just leave it like that, right?
You can leave it just like that. If you could factor it, yes. But there's one thing extra we have to do since we're dividing. When you add, when you subtract, when you multiply, there's no domain restrictions. You can plug in any number. Any negative number, any positive number, you can plug in 0. But when you're dividing, you have to take into account the denominator. You have to say, wait a second. There's one number in this case that I cannot use in this equation because what will happen if I use it? It'll be undefined. So you have to take your denominator in a case like this and say x plus 7. What will give me 0? Right? If I have negative 7, what happens to my denominator? It becomes 0, so that becomes your domain restriction. You would say, I can use any number in the world except for negative 7.
What happens if the question tells you to solve it with negative 7? You just put
Good, undefined. Mm-hmm. Yeah, if it said like f over g of negative 7, you could plug it in and be like, oh, wait, I can't do that because it'll make the denominator 0. Good question. Happy birthday. I just saw it. All right, questions. You guys are just looking at me like, whew. Okay.